All right, so to solve, guys, remember, seems like years ago when we first did this, but if you're going to solve, first of all, if there is not a little number in front of your radical, what do we assume that little number there is? A 2, right? So it's a square root. So like this here is the cube root, that sort of a thing. All right, so, sorry, this is getting all wonky. So let's do number 3. Number 3 kind of brings in a couple things in here. We need to isolate our radical first. Is your radical completely by itself? Now is it? Yes? Yes or no? Yes. Okay, so we need to get rid of the cube root. What's the opposite of cube rooting something? To raise it to the power of what? 3. So if I raise this side to the power of 3, I also have to raise this side to the power of 3. So when you cube a cube root, that goes away. So you have x plus 10 equals. Guys, remember, 4 to the third power is 4 times 4 times 4. It's not 4 times 3. 4 times 4 is 16. Then what's 16 times 4? 64. Good. So now what do I do to both sides? We subtract 10. Good. Minus 10, minus 10. And I get x equals 54. The beauty with x equals a number, what can I do? I can plug it in and check. Should I do that? Yes, get into the habit. Because sometimes, remember, we plug stuff back in and then it doesn't work. And what are those called? Extraneous solutions. Good. So if I plug in 54, what's 54 plus 10? 64. What's the cube root? What number times itself 3 times gives you 64? 4. Okay, good. All right, let's look at something like number 5. We want to isolate the radical first. There's 2 things I have to get rid of before I can solve this. What are those 2 things? So what do I need to get rid of first? The plus 14 or the times negative 3? I got to get rid of that 14. So what's the opposite of plus 14? We're going to subtract 14 from both sides. Good. So you have negative 3 times the square root of 16x equals negative 24, right? Now I still need to get the 16x by itself. So what do? Divide by negative 3. So I have the square root of 16x equals, guys, what's a negative divided by a negative? Positive. So I have positive what? 8, okay. And then now, do I have my radical all by itself? Yes. So how do I get rid of that square root? You're going to square both sides, right? When you square a square root, that cancels out. So you have 16x equals, what's 8 squared? 64. Perfect. And now we divide by 16. And x equals, what's 64 divided by 16? 4. And then we can throw this back in and check. If I put a 4 right here, think about this. 16 times 4, God bless you. 16 times 4 is 64. The square root of 64 is 8. 8 times negative 3 is negative 24 plus 14 gives you negative 10. We okay? All right, let's look at something like number 9. I'll do number 9 over here. I need to get rid of my radical. So the first thing I'm going to do is say, okay, here is my radical. Is it by itself? Yes or no? Yes. So how do we now undo that radical? How do we get rid of it? You square it. We're going to square both sides. So guys, remember, when you square one side, you have to square the other. When I square this square root, this just gives me 2x minus 14. What happens on the other side? Is that x squared and then 49? How do I write that out? X minus 7 times what? X minus 7. It's that quantity squared. So we have to FOIL. So I have my 2x minus 14 over here. And then when I FOIL, x times x is x squared. X times negative 7 is minus 7x. Negative 7 and x is minus 7x. Negative 7 is plus 49. Everybody with me? Do you notice now we have a quadratic? That means we're going to have to move everything to one side and then end up factoring. So I have 2x minus 14 equals x squared minus 14x plus 49. Everybody agree? Now let's move everything to the right side. So I have my x squared and my x on one side. So I'm going to subtract 2x and I'm going to add 14. So when I do that, I have x squared minus 16x. What's 49 and 14? What is it? 63 plus 63, whoops, equals 0. You guys, everybody agree? Okay. So now I say, okay, well, can I factor this? Are there two factors of 63 that'll multiply to give me a positive 63, but add to give me a negative 16? Yep, x 9, x, and 7. What are my signs? Both negative. Perfect. Because a negative times a negative is a positive, and a negative plus a negative is another negative. So I have x equals 9, and I have x equals 7. Everybody with me? All right, so what should I do with those two? Let's check it. All right, let's check. If I plug in 9 right here, 2 times 9 is 18. 18 minus 14 is 4. The square root of 4 is 2, right? So over here, I'm going to plug in 9. What's 9 minus 7? 2. All right, so 9 works. Now let's plug in 7. What's 7 times 2? 14. 14 minus 14 is 0. And then if I plug in 7 here, what's 7 minus 7? 0. Do both of these work? Yes. In all the examples we did last week, remember one of them worked, one of them didn't. So don't just assume, guys. You can't assume both of them work. And then don't assume if you have two that, oh, well, only one of them is going to work. That's not the case. Everybody with me? All right, let's look at something like 13. We did not do something like 13. 13 is actually a really simple problem. How many radicals do you have? You have 2. Are they both the same? They're both the square root? Are they by themselves? Yeah. So how do you undo that radical? You're going to raise it to the second power. Well, what you do to one side, guys, you do where? To the other. So look how easy that is. Now what happens? What are you left with? 3x minus 5 equals x plus 9. How do I solve this? What do I want to do? I want to move x's to one side and what? Numbers to the other? Okay, so I'm going to subtract x, and I'm going to add 5. So this leaves me with 2x equals what? 14. And then I divide both sides by 2, and I get x equals what? 7. All right, let's check to see if that works. Plug in 7 here and here. What's 3 times 7? 21 minus 5 is? How much? 16. So I have square root of 16. All right, now plug in 7 here. What's 7 plus 9? 16. So yes, it works. Good. Everybody all right? We don't have to worry about inequalities. We're not going to get to those right now. All right, how is 14, we'll do 14 and 16, then we'll be done. How is 14 and 16 a little bit different from the other ones that we've been doing? Are they any different, really? It just looks different, right? Because we have a rational exponent. We have a fractional exponent. That's just, you can write that, guys, as a root if you wanted to, but you don't have to. When I am raising to a fractional exponent, how would I undo the 2/3? What would I have to multiply that exponent of 2/3 by to make it a 1? The reciprocal, right? Which would be 3 over 2. So what you do to one side, you do where? To the other. So these cancel out. You're left with 2x. How do I rewrite this? What does 18 to the 3/2 power? What does that look like? The square root of what? 18 to the what? 3rd power. It's the square root of 18 to the 3rd power. Remember, this little number becomes the index. So now you guys look at this and you're like, wait a second. Can I do this? Can I break down the square root of 18 to a perfect square? No. But is there a perfect square inside of 18? What makes 18? 1 in 18? What? 2 in? Huh? Guys, how do you make 18? 9 and 2? Is 9 a perfect square? Okay, so I could rewrite this as 3 square roots of 2 to the third power, right? You guys with me? All right, now let's simplify this a little more. This 3 goes to the 3 and here. So this is 2x equals, what's 3 to the third power? 27. And then this would just be, you could leave it as a square root of 2 cubed. What would your last thing be to do here? You're not using a calculator, so I'm just showing you how you would go through the simplifying process. But what would be the last thing if I want to get x equals? Emma, what would I do? You did it right on your paper. You're going to divide by 2. Perfect. So you have x equals 27 times the square root of 2 cubed over 2. Now, there's no more simplifying other than if you could simplify 27 divided by 2, you'd get a decimal, or if it did work out to a, like if it was 26 divided by 2, you could do that. But you could just leave it just where you're at. The likelihood of you getting a problem like that that doesn't simplify here, it doesn't work out, not high. But you solve it the same way as if it was just the square root of 2 squared, where it would cross out or whatever. You use the same thing. Same thing for this one. How can I rewrite x plus 12 to the 1/2 power? How can I rewrite that? I want to write it with a radical. The square root of x plus 12, good, equals x. If you want to rewrite it as a radical because you like the way it looks better, perfectly fine. If you want to look at that and say it's raised to the 1/2 power, so how would you get that to go away? What would you have to raise it to? To the second. Hi. Sure. You'd raise it to the second power, right? What you do to one side of the equation, you have to do where? To the other. So when you square a square root, it goes away. So now you have x plus 12 equals what? X squared. Good. And then since we have a quadratic, now what do we do? If we have a quadratic, everything needs to be on one side of our equal sign, right? So I'm going to go ahead and move everything to the right. So I'm going to subtract x and subtract 12. So we have x squared minus x minus 12 equals 0. And then everybody's favorite thing in the world to do, we're going to factor. What are the factors of negative 12 that multiply to give you a negative 12 but add to give you a negative 1? What is it? 4 and 3. Good. What kind of 4? What kind of 3? Negative 4, perfect, positive 3. So you have two values here. You have x equals 4 and x equals negative 3. Do we just assume that they both work? No, we have to plug them in and check. So if I plug in 4 here, what's 4 plus 12? I know it's early. 4 plus 12. 16, and then 16 to the 1/2 power is the same thing as the square root of 16, which is 4. So if we get 4 on this side, we have 4 on that side, then 4 works. Good. All right, let's try negative 3. What is negative 3 plus 12? 9. The square root of 9 is 3. But if I plug in negative 3 over here, does 3 equal negative 3? Yes or no? Does 3 equal negative 3? No. So is negative 3 a solution? No, it's extraneous. You can cross it off, or you can write it's extraneous, whatever. But this shows me that, yes, you understand 4 works and negative 3 does not. Does that answer some of the questions that you had as far as solving goes? All right. Do you guys have any other questions? No? All right. Then tomorrow